interviews. So if anything is slow or not working right, yeah, just let me know because I don't really know how it really looks. But yeah, thank you for coming. So I haven't posted a video in a while, and that's because I've been like studying for technical interviews like crazy. So I kind of learned a lot. I failed some interviews. I passed a lot of interviews. So I feel like I have like a lot of advice that I can give. So I was hoping that I could talk about some of the resources I use. And then after that, we can also do some problems. So yeah, and by the way, this is technical interviews that are related to data structures and algorithms. So for example, some companies don't do technical interviews like these. For example, you could get like a system design interview, or it can be like a back end or a front end interview. So just make sure you know what you're preparing for because you don't want to like learn a whole bunch of data structures and algorithms, but then your actual interview doesn't have it. So yeah, so that's just one thing. So yeah, I'm going to come to this technical interview study guide by Eric, Champagne Coder, in a second. But first, I kind of want to tell you like one of the first videos that I watch. So to anyone that doesn't know like what a technical interview is, I think this video by Back to Back Sweet explains it so well. And something else that I like is that he's very honest about his process. And I hope that I can be like really honest with y'all as well. So for example, in this video, he said he did 250 leak code questions in order to prepare. And for me, I did around 200 in order to prepare. So it's a lot of work. I don't think anyone really just like knows all these questions and how to solve all these problems. But yeah, I definitely think this video is like such a great resource. So then something else that was such a great resource was this study guide by Champagne Coder. So if you want to visit it, all you have to do is use this link in his bio. And why I really liked it, and yeah, that's the link right there, is because it kind of gave some structure to my prep that I was doing. So I did use like a Trello board in the past in order to do technical interviews. But yeah, I kind of like fell off a little bit. However, this was actually like, like a method or like a visual representation that really works for me. So on the left-hand side, you can see like he lists all the different topics that you need to know if it's like a leak code specific interview. So I can show you mine as well. So this is like a newer version of it. I kind of use like an older version of that study guide. And like after a while, I like stopped filling it out once I got more comfortable. But like you can see like it's the different topics. I would put like the number of questions I solved. So it's a little different from the other one. Like this one's like 1 to 5 for each level or something like that. But yeah, this really helped me just because I got to a point where I was like, I don't know if I'm making progress. And when I feel like I'm not making progress, that's when sometimes I quit. So using this, at least when I was starting to see like all the yellow on the page and starting to see everything, I was like, okay, like I'm actually making progress. And I would actually take notes too, like graphs. Oh, feels so good. First graph problem that I did on my own. But yeah, I would take notes and different things like that. So you can see on this header, I put like graphs, problems, like whatever concept it was. I still didn't fill out everything, but like whether I solved it, the type of graph, the complexity. So for example, if it was like O of V plus E or something like that. So yeah, that is what I use. And then something else I wanted to shout out as a really good resource that I use for these technical interviews is this podcast. I love this podcast so much. Oh yeah, Back to Back Sweet is amazing. Yay, Jeremiah's here. Nice. Okay. Yeah. So this podcast was everything. I would listen to it all the time in my free time. And the reason why I liked it was that the people who have this podcast, they are so good at explaining different topics. So it was kind of like a great introduction. So if I go back to this study guide over here, I'll go to the newer one. It was like study a book chapter on it or watch a lecture on it. I would use that for either or section. So I would like change the status of that. But yeah, this was a great resource that I use. I started with like the linked list was I think the first one that I really started watching with them. But they cover linked lists, stacks, queues, trees, binary searching, and that's like all topics you need to know. So I just think this podcast is amazing. So then I wanted to shout out some YouTubers who kind of do these types of questions and that like really helped me. So later on, we're going to do a DFS type problem, and how I learned DFS like Michael Munoz, and I hope I'm saying his name correctly, has a really great video where he covers number of islands, which is a leak code problem, and he covers it like the DFS way and the BFS way. So those are all ways that you can like traverse like a data structure, like a tree or a graph. So I just think that he's amazing. And then other YouTubers as well that I want to shout out that has like, great solutions to these types of problems is Kevin and then also Nick. Yeah, so for them, the way I use these resources was usually when like, okay, I would try a problem and then if I couldn't figure it out, I would just like type it into the search bar, whatever that problem was. And these two videos would always pop up. So I use those resources all the time. And then also back-to-back SWE. So I talked about the back-to-back SWE this video, which was a great introduction, but he is just so great at like breaking things down. And he's one of the few YouTubers that actually show like the recursion and kind of like how the problem goes. So I definitely think this is a great resource. And I'll have all these resources like in the description box. I'll save this live stream after. So yeah, these are all resources that I really liked. So then now I think it might be a good time to go through some problems. So the problems that I wanted to cover are maximum depth of a binary tree and then also number of islands. So in all the technical interviews that I did that were like data structures and algorithms related, like for those companies, I either saw BFS or DFS in one of those rounds. So with technical interviews, it's not just like, or at least for the companies I applied to, it's not just one round of technical interviews. It was actually like 4 hours. So 4 rounds and then maybe like one behavioral, or they split it up like half technical, half behavioral in every interview. So I noticed that this was a big trend that DFS and BFS always showed up. So I was thinking this time we could cover DFS. And then if this goes well, next time we can cover BFS. So yeah, that was what I was thinking. Okay, nice. Oh, algo expert. Yeah, I hear a lot about stuff. Okay, nice. So I'm going to try and like ask y'all some questions too. So definitely feel free to write that in the chat. And yeah, I'm glad this is going well. So if this was a real technical interview, so let's say I was given this, what I found out most of the time, what would happen is, okay, yeah, I can definitely do that. What I would find out is most of the time what you're given is just this part of the question. So you're not given like, like the title of it, or you're not given diagrams or anything like that. It's really just this part. So if this was a real interview, I'd probably just read the question out loud. So given the root of a binary tree, return its maximum depth. So I feel like that's always the first part. I know some people like read the question in their head, but something I realized that really helped me for technical interviews, and my friend, she works at Twitter, we would talk about it as well, is that we kind of just don't stop talking. And that might sound weird, but the interviewer, they can't read into your head and they don't know what you're thinking. And one of the things they're kind of like grading you, or they're looking for people that are really good at communication. So if you're just always explaining what you're thinking, like you're already getting some points in the interview. So that's something that like really works for me. So yeah, so this is usually what you're given. So like, let's say I was in the interview and I just started typing something. Like I just started going. You have no idea like what my algorithm is. You have no idea where this is going. So let's say I do get stuck, or maybe like, like the syntax is wrong or something like that. You can't help me if you were the interviewer because you have no idea what I'm doing. So one of the first steps that they really want to see, even before you even start thinking about the algorithm, is asking those clarifying questions. So that was something I would do. So the way I would actually write it is I would type out requirements. So like if you could actually see the notes for my technical interviews, in all the ones you'll see that I write out requirements, and I'll start asking questions. So for example, if this was the question, one of the first things I would probably do is I would clarify what the definition of depth is, just to make sure we're on the same page. So for example, they wouldn't give you an example, but this is where you can start saying like, okay, let's say I have a tree that looks like this. And in this case, you won't have like a perfect tree, but you would probably have to like, start like drawing it out, which can get kind of like weird, but that's actually what I would do. Sometimes what you can also do is say, can I have an example, to see what you mean, or you can come up with the example yourself. So like I'm kind of nervous for some reason. So I'm not gonna like type out this entire tree, but instead we can just look at the example for now. But that's something I would do in the interview. And I would say something like, okay, so like if this is the tree that we have is the depth 3, and then give my reasoning because there's like 1, 2, 3 levels or something like that. So that's what I would do. And then the interviewer would be like, yeah or no or something like that. And then after that, I'll start asking about some of the constraints. So I'd actually type that out in the interview. And I got really good feedback for doing this as well. And I'll say something like, okay, for the input, like what is the smallest input that we can have? And then they might say, okay, smallest, like you can see in this example, would be like, null or none. And I'll just type that out here. And then I'll be like, okay, what is like the largest input that we can have? And then they might say something like, I noticed they'll either say something like, okay, a really big number, or they would say, maybe 10, along those lines, whatever the interviewer is feeling. So I might say like, okay, we can have very large input if that's what the interviewer decided to say. So then after the constraints, I would ask the interviewer, like, do we have to worry about like bad input? So for example, you see over here, we're given like integers. I would say like, oh, could we be given, for example, like a string? And if we're getting a string, maybe we have to return something else. So usually what they would say is you don't have to worry about bad input. So I would say like, no need to worry about like invalid input. I think that's kind of like a better way to say it. And yeah, I'll just keep going through this problem and trying to get those clarifying questions. And I feel like also the reason why this is so important is because on the real job, they don't want you like to be given a problem and you just immediately start typing, like start writing code. They want to see like, okay, do you really understand the problem? Like, are you the type of person to ask those clarifying questions? So yeah, definitely spend some time doing that. So like no need to worry about invalid input. And then I would probably say like, okay, we looked at the values of it. I would probably give another example as well to see if I understood what the depth meant. But then after that, I would be like, okay, I think I understand what this problem is and what we need to do. So then after that, I actually write down ideas and I'm like, okay, let me try and brainstorm some ideas to do. So in this case, when it comes to these trees, what my brain usually goes to is DFS and BFS. So what I would do is actually type that out and say like, okay, I'm not sure which traversal I want to use. However, DFS and BFS are popular tree traversals. So I think I want to explore both of these ideas and see which one will work best for this problem. So when you say that, it kind of shows the interviewer that like, you just don't jump to one solution immediately. And it shows how you actually think about like what the different possible options are. And that can help you, like choose what is the best algorithm. So for example, DFS is a depth first traversal. So that's more about going like as deep as possible. And then after that, you kind of like backtrack a little bit. So for example, I actually have this like web paint thing. So hopefully let me know you can also see that. But for example, if I was doing depth first search, I would start at like the root node and then I'll look at the next node. And then after that, I would keep going to the left until there's none here. And then when there's none, I'll probably have a base case to like, go back up. And then once you have fully explored, like, like that left subtree over here, as y'all can see, there's like no node over there, then you'll start looking at like the right subtree. And then, there's nothing there, there's none. So when you see none, all you do is like return. But as you can see, I'm going like as deep as possible as I can with this tree. So that's kind of what depth first search is. And I'll definitely have resources that can, explain that maybe a little better as well. But now, let me pull that back up. If I was doing like breadth first search, that's more of like a level by level traversal. So for example, I would look at 3, which is its own level, and then I would look at 9 and 20, which is the next level, and then 15 and 7. So yeah, so those are different traversals that I use in, all those different technical interviews that I did. So for this problem, let's just clear that up. There's those two things. Okay, nice. That we could use. So I'll probably say like, if I did decide to do depth first search, what I would do is I would, so with depth first search, there's like the different traversals that you can do with like the pre-order, in order, and then the post order. So I'd probably say like, it doesn't really matter which traversal that I use for this one, as long as I kind of kept track of, every time I did the like recursion, when I like, went down to another subtree, and hopefully, yeah, this is making sense. Okay, cool. And then also I would do the same for like, the right subtree. I would keep traversing and kind of like calculate the depth as I go. However, if I did do BFS, I would use a queue to help me solve that problem. And it would be more level by level. And what I would do is every time I got to a new level, I'd probably store that in a variable. And that's the variable I would like eventually return. So yeah, hopefully this is making sense. If this is making sense, can you write something in the chat? And hi, Web Dev Junkie, William. Thank you for coming, by the way. Okay. So yeah, so I would like write that down. I probably wouldn't write out all the steps. So I'd probably like at least write DFS and BFS. And then, yeah, I'm going to choose to do DFS. So now we can start talking about actually like the implementation of this. And before I didn't really like, like tree type problems. However, when it comes to doing DFS, I noticed that it was like very similar, like the template, like when I write the code, when I do DFS. So for example, I could show you like 10 different problems where I solved it with DFS, and you would see like the base code looks really similar. So let me actually show you what I mean by that. Okay. So let's say I was doing the base case. So if root is none, in that case, let's say we wanted to return 0. So for example, if we're given null or none, that means like, there's nothing to do. So we can just return 0. So then what I'm going to do is I want to kind of explore the left subtree. So this is a recursive algorithm. So let me just copy that. And then as you can see as well, we're given information about what a tree node has, and it has a value, a left, and a right. So I can definitely do like root.left. And let me actually show you like this template that I mean. So after you're done exploring the left subtree, you explore the right subtree. So that's exactly what I'm doing here. And let's actually print out root.val. So then I would love it. Please zoom in on the code. Got it. Okay. Hopefully this is better. Thank you for that. Okay. So then I would like you to tell me that if this is the input, in what order would you see the nodes printed out? So I kind of have the print statement between like, exploring the left subtree and exploring the right subtree. What would you see printed out if this was basically the tree? So I'll give y'all some time to kind of like think about that. So this would be an in order traversal, but I would like to know what y'all think the answer would be. And actually, no pressure. I hate when people put pressure on me. So just think about it. If someone does want to say, you can say it. But if not, I can run the code and kind of show you. I'm using Python, by the way. So this is LeetCode too. I didn't really say the website I'm using, but LeetCode is like the website that I use for these technical interviews. So good. But yeah, you can see that the order that everything was printed out was 9, 3, 15, 20, and 7. So if you did get that right, nice. And something that I would notice with these DFS problems is that like, this is basically like the code that I could type out like really quick just because it follows this format, but you just have to make like 1 or 2 changes in order to make this work. So if someone did want to put in the chat what you think, what I could add to this code to make it work, then I would like love that. I'm trying to make this interactive. It's hard. I know some people 9, 3, 15, 27. Okay, nice. Marcia, I see you. Coding Paths, I see you. But yeah, so we're trying to calculate the depth of this. So how do you think we could do that with the code that we have? I feel like I'm like Door Explorer trying to be like, hey, what do you think we should do next? But yeah, I just moved the print statement. So now this is a pre-order traversal. But yeah, definitely look up pre-order, in order, post order to learn more about that. But yeah, memoize. So memoization, using that with this. Let's see. So memorization is like when you can save some of like the traversals that you have, like the results of it. So a question I really liked that I kind of understood memorization more was like Fibonacci. So for example, when you do different things like when you're calculating the recursion of like, let's say it was like fib of n minus 1 plus fib of n-2, it's going to get to a point where you're like doing the same calculations over and over. So you could have like a cache and type and like store some of those results as you go. So I see that. I'm not sure if I want to memorize right now, but there could definitely be a solution that works with that. So instead, what I'm going to do is if we stored this, the results of this was like, let's say this was the left was equal to that, and then the right was equal to that. So we definitely know when you hit like the return one plus. Nice, exactly. So that was exactly what I was looking for. So what I was getting at was like, let's say you're traversing this tree. So you know when you hit none. So you keep going left, left, you're going to eventually hit none. You know you return 0. But you want to see how you can actually kind of like calculate that depth as you go. So then Corey McCarty has exactly the solution that I use, where you can use something from the math library called math.max. And what you can do is actually take the max of what you see. So for example, like when we look at this number 3 and we're calculating depth, so I'm looking at example 1, like that subtree, like let's say on the left-hand side, the depth of that is 1, but then on the right-hand side, you can actually see that the depth of that is 2. So we don't want to take the 1, we want to take the 2. So that's where like the math.max comes in, using that function, just because it can help us get the bigger one. And then each time, yeah, go Corey, we're going to do 1 just to include the node itself. So let me type that out so y'all can see. So I'll just do it like so. And if I'm not explaining this right, y'all, it's the first one. I'll get better at explaining it. I think I can actually just type max. I turned off autocomplete. So yeah, so like when we come to like the 3, being the root node situation, we're doing 1 to include that root node plus the max of like the left subtree and the right subtree. So let me just take out that plus and instead put a comma there. And yeah, let's see. I could be missing something. Okay, nice. So this one worked. So was there anything that you would do in order to improve this? Or is there any test cases that you would like to try out? Oh, thanks to come up. Nicole is here. Nice. Yeah, I'm like so nervous, guys. So thanks for doing this. But okay, yeah, let's try out these different examples here and see if it gives us the correct output. Okay, nice. So this one's a little bit different. Let's see if we actually got that edge case over here. And then try out this one. Go through all the different edge cases. So one of the good things about technical interviews is that you kind of come up with like the different test cases that you do. And why that's cool is that like when you submit it on LeetCode, they might have like 100 different test cases. But kind of during the interview, they kind of want to see if you have like the basic algorithm correct. So yeah, that's what you can do. And yeah, what I would do now in the interview is I wouldn't just say like, okay, I'm done. I would actually go back to the requirements and say like, okay, did I deal with each of these different constraints? Then I would also make sure some viewers will experience buffering. Okay. And then, yeah, I would say I don't need to worry about invalid input. So what we can do is we can submit this. We can see if we need to change anything. And then nice, success. So then I'm not going to worry about like, like the speed or the memory usage or anything like that for now. But would someone actually like to say what would be like the time complexity of this problem? Just because in the interviews, that's usually the next question that they do ask is like, what is the time and space complexities? So feel free to, and then if you don't know what time and space complexities are, and then Corey, oh, my hair got stuck, says it also gives you room to demonstrate your understanding of the edge cases when you can come up with proper test cases. Exactly, 1000% agree. So yeah. So then when it comes to, let's talk about maybe like the time complexity. So I'll talk about the time complexity, then I'll let someone maybe talk about the space complexity of this. But what it looks like we're going to happen is depending on what the input is. So for example, we were given the root, and I just love this diagram of it. As you can see, remember when we were printing everything out, we printed out like every single node. So like 3, 9, 20, 15, 7, like we saw all those values on the screen. So because of that, depending on like the size of the input, and let's say like the size of the tree, we can represent that as n, which is, like that's what n represents. It'll be big O of n just because we do look at every single node in the tree. So yeah. Okay, nice. Oh, I love this participation. And I wish I could hear y'all so you can also add back. Is there an algorithm that tells you the time / space complexity? So there is like a cheat sheet that I use all the time. So it's like the big O cheat sheet. So if I go here, this is something that I use a lot. So we can see right now. So this binary search tree is yeah. So, and they also have like array sorting algorithms, but yeah, this was helpful in that. But let's go back to the problem. Okay. Yeah. So big O over n. And then, yeah. So then they said the space complexity was big O of max height. So because of that, when we think about that, so right now, when I think of space complexities, the way I would look at it is I would see, is there any data structures that I'm using? However, with DFS, it's a little bit different just because you have to think about the recursion and like, like the stack. So what's going to happen is you have to think about like at max, what is going to be on our stack. So for example, if we keep going like left and looking at the left subtree, and sorry, there's people yelling really loud at my house, so I hope you can't hear that. But yeah, you have to think about like what will be on our stack and when we return. So I don't know if I could like draw this out to have explain it, but like, when we call our function, first we're calling like max depth of like, 9, or it's not 9, y'all, of 3. And then, we call self.max depth of root.left. So then after that, it's like max depth of 9. And then again, we go to line 24 and we call it on root.left again. So then we're going to call it on like max depth of none. However, when we call it on none, we've reached our base case. So you can see that was like the height of it. And then when we reach our base case, we just return 0. So then right here, now we have 1 plus 0, right? But now we're at this 9 situation. So we're going to call our recursion again, but now we're going to call it on root.right. So then we call it like on max depth of none. And yeah, we keep going. I'm not going to go through the whole thing. You're writing behind your camera view. Dang it. Okay. Let me do it over here. Y'all, thank you so much for participating, by the way. I appreciate that. but we call max depth on 3, and then we called it on max depth of 9, because we keep going root dot left, and then we call it on like max depth of none, and then none is our base case, so we return 0. So that's how that max depth has 0. And then we go back to the 9 just because that's the top of our recursive stack, and we just keep going like that. So that's why it's max height. So yeah, 23 watching. Nice. My goal was 20. So we did it, y'all. But I think I'm going to do the next problem a little bit differently, because I feel like it was kind of weird to say, like, if I'm in the interview. So I think I'm just going to pretend for this next problem that I'm in the interview and solve it like that. And let's see how that goes. So yeah, we just did DFS on a tree. Now let's do DFS on a graph. So I'm just going to pretend like this is the real interview. So I might just be asking questions. No one's going to answer, but y'all got me. Okay. So number of islands. Given an m by n 2D grid map of 1's land and 0's water, return the number of islands. An island is surrounded by water and is formed by connecting adjacent lands horizontally or vertically. You may assume all 4 edges of the grid are all surrounded by water. Okay, I think I just want to try and understand this problem more. So I'm going to try and look at the example you gave. So if we're given this grid, so I'm noticing that it is a list of lists. So nice. So for this problem, I think I'm going to start writing some of the requirements down to make sure I understand this. So, okay. So can we assume that the grid that we're given is always valid? Okay, nice. We can assume it's valid. I'm really talking to myself out here. But okay, so we can assume the input is given as valid. So something that I'm noticing as well, that it's like strings and it's not like integer values of the ones. So that's something to notice. And then something else. So I know the type of it, like you said, it's going to be valid. It's going to be strings. However, can we also be sure that it's either going to be a 1 or a 0? Okay, nice. So y'all gonna think I'm crazy talking to myself. Okay, 1 or 0 as input. We can be guaranteed that. And then also input is, well, strings. So that's kind of, yeah, okay, cool. So nice. So then you said 1's is land and 0's is water. So looking at this, I'm noticing these different ones here. Okay, so the output is 1. So it's saying that it's 1 island, and it's because these ones are connected. Okay, all of these different ones are connected, and that makes an island. So that makes sense to me. I think I'm gonna think about, so for the output that you're giving us, or the output that you want us to return, it's also going to be an integer or a number. Can I make that assumption? Okay, nice. I need to stop. Okay, so then let's look at this example as well. So I see that the ones going like up and down, like in this first quadrant, you can say that's 1 island. And then the one here, that's like another island. And then like the ones at the bottom is an island. So that makes 3 islands. Okay, that definitely makes sense to me. So I kind of want to talk about kind of like some of the constraints of the problem. So I know the constraints are given here, but usually they're not given. And yeah. Okay, cool. Everyone's still with me. So yeah, so they explain the constraints. I kind of talked about this one. It talks about like, like how long, like the rows and columns, how many rows and columns we can have. But nice. So now I'm going to start thinking about different ideas that we can do to solve this. And when I think about grids, I think about traversing it like left to right. And then I also think about using DFS or BFS. So I'm going to see which one will work in this situation. I kind of want to start exploring DFS first to see how that would go. So let's say I was traversing this grid from left to right like so. And I started off at this 1. So we know ones can make an island. So let's say I started running, a DFS algorithm every time I see a 1. So what I could do is I could traverse this grid, or I can call that DFS algorithm. And what I would do is I would want to go in the different directions possible. So for example, I would want to go up, but there's nothing there. Then I can also go down and I see there's a 1. And then if I was doing DFS, it would want to go as deep as possible. So it would see another 1, but then when it sees a 0, that's kind of like one of the base cases, because when you see a 0, that's not part of the island. So you just want to return. And I think something we can do as well is, since you told me what the valid input is either like a 1 or a 0, what I could do is once I like see one of these, I can change it to be a different symbol. And that kind of marks if something is seen. So also, if anything is seen, we kind of don't want to see it again. So that is also one of our base cases as well. So for example, every time, like the first time I see this 1 over here, let's say I change it to a $sign, and then I see this 1 and it's a $sign, because I'm kind of like going as deep as possible with DFS. I see a 0, that's my base case, so I return. And then I'll try and go in like every direction as much as possible. And then I know when these are all $signs, that's kind of like a, connected component or an island, as you may call it. So yeah, does the algorithm kind of make sense to people? If so, sorry, I'm talking so much. Okay. So then if this was an interview, I would start writing this out. Okay, so that's the algorithm I'm thinking about. Does that make sense? Or do you think I should explore like the BFS solution? And then they'll probably say, yeah, that makes sense. Okay, so then now let's do number of islands. So in a real interview too, you wouldn't even be given this kind of starter code. You would have to like write that out yourself sometimes. So, but I'll just take that. So now what I'm gonna do is we can start traversing this. So let's do that. Also looking at the constraints too. Okay, so it's given that it's at least of size 1 for that. So, okay, so for I in range length of grid, and then for J in range length of grid at I, what we're going to do is we're going to have another function called DFS. And what we're going to do is pass in I, J, and the grid. And we're also going to have a variable as well, which is going to be called like, num islands. And at first that's equal to 0. And then after we call DFS, so that means we explored all the different ones that are possible, we can increase the number of islands. Oh yeah, and I need to add an if statement as well. But we can increase the number of islands by 1. However, we only want to call DFS if what we're at is equal to a 1. So if the grid at ij is equal to a 1, then in that case, we call DFS and the number of islands increase. And then eventually what we're going to do is return the number of islands. Okay, but now let's actually define what this DFS is going to look like. And then let me also do self, because I'll pass in self here. And we have I, J, and grid. Okay, so now we have to think about all those different like edge cases we were talking about. So ones that we didn't talk about is when you kind of get to like the edge of the grid, just because like when you do that, like let's say your I is equal to -1, there's no way that that's like, possible. So what you're gonna do is just like return in that case. So let me kind of like write what that would look like. So for example, if I is less than 0, or J is less than 0, or I is greater than or equal to the length of the grid. And I hope this isn't being covered or anything. I know last time that was kind of like a problem. Maybe I'll zoom out. Okay. Let me know if you can see that. Or J is greater than or equal to the length of the grid at I. So if that's any of the cases, what we're going to do is we're going to return. And then also we talked about the different situations of if the grid at ij, and then notice how I just like don't stop talking even when I'm writing code. That's something that I just did. And yeah, even if I'm just saying what I'm doing, is equal to, I think we use the $sign, but you can say anything that's just not a 1 or a 0. And then this doesn't have to be a separate if statement, but we will make our code cleaner at the end. Okay. Is equal to a 0. We're going to figure out what to return. And then we're talking about doing the DFS in like all of the different directions. So we're just going to do my throat, y'all. I'm sorry. Okay. Woo. Okay. So then you call self.dfs. We're going to call it on I+1 j grid. And then let me just copy and paste that. I-1 j+1. Oh, my throat is so dry. Y'all are probably like, what is this girl doing? Okay. And then something important that we have to do as well, I'm going to explain what I'm doing here, but we actually have to change it to be like seen. Okay. So let's actually walk through what all of this is doing. Okay, you can just set it to 0. Oh yeah, that's a good idea too. I don't actually have to do that. And let's just do that as well. So let's walk through this to see if I have any errors and we can fix it. Okay, let's erase this. And let's do example 2 while we walk through this. So notice how I didn't say like, oh, I'm done, you know, like I know I still want to like maybe make some changes to this. So I'm like, okay, let me walk through this. So in the very beginning, well, I'm not going to use that just because I wouldn't use the paint tool in the actual interview. I actually like write it out. So going through example 2, the number of islands is equal to 0 in the beginning. Now we say for I in range length of grid. So we're going to go through the length of the grid. And now for j in range length of the grid at I. So if grid at ij is equal to a 1, so in our case it is equal to a 1. So we call self.dfs on 0, 0 grid. So that's kind of like the first recursive call that we do. So let's actually jump to the DFS that we have over here. So it won't go into any of these if statements just because, you know, it's not at any of those error boundary cases. It's actually at like a position. So we don't go there. It's also not equal to a 0. It's equal to a 1. So now we set it equal to a 0. So now in our case, that's not a 1 anymore. It's a 0. So now we call self.dfs on I+1. So now that's going to be, we're going to call self.dfs on 1, 0, and grid. So now we're going to do that again, and we're back at the top here. So we're not in any of those positions, you know, any of those error boundaries. And we can also combine these, by the way, but we're not here as well. So because this is a 1 right here. So now we make this equal to a 0. So right now, this is a 0, that one's a 0. And now what we're going to do is call it on I+1. So we're now at this position over here. So what's going to happen is you can kind of see that it's highlighted, but when we call DFS again on lines 24, it is equal to a 0. So we're going to return from that like recursive call, and now we're back here. We're at that 1. So now what we're going to do is we call it on I-1. So on I-1, it's actually going to take us to the 1 that's above it. However, at that case, it is equal to a 0 because we did change it. So what we're going to do is we're going to actually return. So we're back to this position over here. So now we're going to call it on j+1. So we're going to look at the one that is to the right of it. And you're going to see that that is equal to a 1. And then we just basically keep calling like, you know, the recursion on it. And we're just going to keep doing it like that. And yeah, I kind of didn't like walk through anything, but that like I didn't type out anything. But yeah, that is what I'm thinking. So that in some like situations, you are able to run your code, so you can use that to help you fix some of your errors. But let me definitely comment this out as well. But in some situations, you actually like don't run your code just because it looks more like a Google Doc. So then after that, after I think it works, I would go back to requirements and I'll say, okay, it was a valid 1 or 0 as input. Input is strings. Output is a number. I am outputting a number over here. And then after that, I would try some of the different, edge cases and error cases. But yeah, I see someone is saying, why do you need the $sign? Yeah, we just use a 0. When I need to comment things out, comments. So you could write comments. I'm trying to think what I did. I usually didn't write comments. After I came up with the algorithm and me and the interviewer both agreed that it was okay, I kind of just focused on like typing it out. So that's something I did. And then you can also have the different directions array. Yeah, that is also a great idea of what you could do as well. So like you don't have to have like all of this like repeated code. You can do it another way. However, this is just like so clear to my brain, but we can also combine this as well. So it's equal to that or this. You return. Oh, oops. Oh, don't forget the string part. Okay, nice. And then, yeah, we can see if we're missing anything else. Let's try it on this example as well. And then if anyone has any questions as well, just let me know in the chat. But like, yeah, one good thing about LeetCode Premium as well is that like, if you're a little shaky on the recursion, what I would do is I would actually like run the debugger on it. So I would do it like that. And then it's taking some time to run. And okay. I don't think it's, hold on. Okay, let's try debugging it again. Hopefully this works. Okay, nice. So then it actually like steps through everything. And especially when it got to like the recursion part as well, that was just really helpful for me in like visualizing everything. So yeah, that's something else you can do. But let's see if this works for this example as well, example 2. If not, we can fix it. Okay, nice. And then let's see if there's any errors. Okay, cool. So yeah, so those were the 2 examples of DFS that we did. Does anyone have any questions on like technical interviews in general? I just chose to do DFS just because I saw that in like all my interviews. But yeah, I think this template, this study guide is everything. And yeah, Champagne Coder came up with it. And it just really helps me to like, to keep my, my studying organized. So at this part, I'd probably like come in here and I'll be like, okay, so tree traversal, we did that problem first. And I would be like, okay, this is like 1 out of 10. And then like graphs as well. I can probably just take you to the one I actually did. I'd probably like, just to show that I'm like progressing is what I would do in that situation. But yeah, that's what I wanted to cover, y'all. Any questions on that? 16 people stayed. Hey. Yeah. Okay. If not, any questions, we can. So I'm just looking at the chat, y'all. We can. How long did we spend on this? Okay, nice. We started at 1:30. It's almost 2:30. I think that's how long I wanted to take. Oh yeah, first year tips. Yeah, my first year of computer science was so rough. It was really hard. But I think at the same time, I was just new to coding and new to everything. And I kind of just had to give myself time to, learn computer science. I think we can fall into the trap of comparing ourselves to others, but it's like if someone was coding since they were, since they were 12 and you're comparing yourself to that person, it doesn't really help the situation. And even if someone else is new to coding, at least for me, I had to learn how to like problem solve and like critically think. And that was something that was just like new to me. Like in high school, I was just memorizing everything out here, which is pretty incredible how much I did memorize. But, when it comes to computer science and coding, you can't have all this memorized, like all these different topics, y'all. Like, it's just like, it's so much. So you really have to learn how to be like, okay, what is DFS? It's going as deep as possible. How can I go as deep as possible? And kind of, go down that like train of thought. So that was one thing, one advice. Another advice would be to, challenge yourself. Looking back at my first year, I just didn't challenge myself as much as I should have. And going back, I wish I would actually like spend more time just like in front of my computer, exploring different things. When you're given a problem or an assignment, like let's say this is the code you're given, like comment things out, change different numbers and stuff like that and see like how that affects the problem. And then also, when it comes to technical interviews too, I would always go to the discussion tab and I would say, okay, how did they solve it? So, for example, BFS. We didn't use BFS, but BFS is another way to solve this and like actually spend time solving it a different way. That is something that's like so helpful as well. And then, yeah, don't be around toxic people too. If there's anyone telling you that you should give up or this is not for you, you do not need to study or be around them just because anyone can learn to code. Like I struggled so much, but after practice, I became better and you can too. So yeah, those are some advice. Nice. Yeah. So I used to do technical interviews in Java just because Java was like, the first language I learned, but I definitely feel like Python is like the way to go just because like look at this. Like the syntax is just like so much easier and it's like I think the Java syntax would probably be pretty short as well. Let's see. Another pro, LeetCode is not sponsoring this, but of buying the LeetCode subscription is that you do get to see the solutions. So this is the Python solution that they did. Nice. So you can see it's what we did as well. They just kind of broke it up a little bit. And then the Java, yeah, it's very similar. Yeah. But with some other problems, it's like Python has all these built-in libraries that it just makes it like way easier. And then negative indexing in Python too. I love that feature of the language so much, and it worked a lot. Yeah, Python is very easy to think in. And then does GPA matter in getting internships or placement in tech giants? It actually depends on the company. So for example, Google does ask to see your transcript. And I think if you have below a certain GPA, they would be like, hey, why did you do that? Just because they have a whole hiring committee that you have to go through. So like would have to explain that. However, there's other companies, for example, Amazon, they didn't ask for, your GPA. So it kind of just depends on the tech giant. Okay. Best way to get started with Python. Can you jump in the most basic problems on LeetCode? Yeah, I can definitely do that. And for Python and JS, you need to be careful about time complexity when using syntactic sugar or built-in functions. Yeah, that is totally true. I have definitely been in situations or I've done problems. So for example, let's say you had like, let's take it outside the comment. So like your nums array is equal to, and then you do something like nums.sort. Does anyone know what the time complexity of that would be? Because for example, you might just look at that and like, because it's easier to think about time complexity when it's like a for loop, for example, because when you see a for loop or a nested for loop, you kind of know that's maybe big O of n or big O of n squared. However, when it comes to this, the sorting algorithm that Python uses is actually n log n. So you have to be very careful with using the built-in functions to remember like the different time complexities of them. So yeah, that is a great point. And then yeah, we can go to a super basic problem as well and see how that's like. My school had to start with C, C++. I had no experience with coding prior to starting the CS degree program. Yeah. So the first class I took, we had to code it in Java. And then the next class I took was a data structures class. And we had to code that. We had to code data structures in Java, C, and C++, all for one class. And that was so bad. I barely understood Java at the time. And then we had to code it in all those different languages. So yeah, that was definitely tough. But we can definitely go to another problem as well. So something else that I like, I don't know if this is a feature of like LeetCode, but you can actually create different sessions. So like, for example, maybe I'm doing this like live stream and I don't want to like, mess up, the number of problems I've done for another part. You can just do that. But yeah, I always like creating different sessions as well. But anyway, let us look at a very easy problem. Or I don't even want to say easy just because like as you can see, I did like a lot of different problems when I was like, is it on the me one or the anonymous? Yeah, I was putting in work, y'all. So nothing is easy. It just took a lot of practice. But let's go back to the 3 days one. Okay. So if you can sort it by difficulty, and we can do a really easy one. So let's see. Let's do this one, running sum of 1D array. And I'll have that person that put that comment in explain it. So reverse string in Python. Yeah, that's a good one too. So this one is running sum of 1D array. Given an array nums, we define a running sum of an array as running sum I equals the sum of nums 0 through nums I. Return the running sum of nums. So for example, we have this is our nums, and then the running sum is obtained as follows. So we see a 1 is here, and then it does 2 plus 1. Nice. And then 1 plus 2 plus 3. And then, okay. Nice. So for the person that wanted to do this problem, is there anything that you want to see for this one? I think the person is the daily chose. How would you go about solving this problem? It doesn't have to be the most optimal way as well. How would you go about doing it? And then, yeah, no pressure as well. I hate when people put pressure on me. So, I mean, I don't think y'all want to just see me solve problems. But if I was like, I think the first time I solved this, I started off with a for loop. However, there's a way they can do this in one line of code. So definitely someone can put that there. But what you can say is, let's say you had output is equal to the empty array. So we basically, at the end of this, we want to return output. Now for I in range length of nums, what you're going to say is output.append, and you have to figure out what do you want to put there. So what you can do is you can also have like a sum variable as well. So you can say temp sum is equal to 0. And then what you could do as well is now temp sum is equal to, or you can use the shorthand of whatever is at nums of I, and then you can append temp sum. So for example, it's going to start off as 0, and then you add that 1, and then you add 1, and then it loops again, and then it's going to add 2 plus 1. And then let's actually print that out to see if that's working. And yeah, but does someone have a better way to do this? Nice. Y'all are so good. Recursive iterate by index. Oh, recursive iterate by index. Use recursion for this. I'm trying to think what the base case is. I'm not sure. Yeah, I'd love to see that solution. I'm not sure what you mean by that one. Reverse string, return reverse string. that plus string 0. Yeah, that's coding paths. I see that. That's a really good one as well. But yeah, for the person that wants to see that, there are more simpler problems as well. I know for me, that's how I kind of like did these. I would go to like the data structure I felt more comfortable with. And in the beginning, that was arrays. And then I would sort it by frequency, was how I chose different problems to do. So you could do like difficulty or frequency or acceptance as well. Yeah, so there's even other problems you can do as well. But yeah. Any other questions, y'all? Yeah, no problem. Yeah, definitely make sure you start with the easy problems. I know for me, I was like, oh, I've been working in industry. I can go straight to medium. No, at least for me, I had to start off with the easy ones first, especially for like harder topics like dynamic programming. That's a topic that still sometimes trips me up. So definitely make sure you start with like the easier problems first. And yeah, if there's any more questions, I'll answer it. But if not, I appreciate y'all. Thank you for coming. This was fun for me. I have not posted a video in so long, so I'm happy to do this live stream. And yeah, any other questions? Well, I'm kind of glad that I did this as well, because this is my first live stream. I was just always like worried about doing a live stream because you never know what craziness might happen. But yeah, nice. Okay, thanks, y'all. Oh, y'all are still here too. Cool. Okay. Okay, I'm gonna try and end this then. Okay, cool. Thanks, John. Appreciate that. And I will end this.